Yeah, my talk is called, well, first, that's me. That's my talk. My talk is called Value, Money and Costs, the ultimate common language for testing strategy. This is how my wife sees me with the dogs. So yeah, I'm a developer. I've been a QA, an engineering manager, a mentor, and now I'm a developer advocate as well. I am a quality enthusiast. I, as many of you, I'm sure, believe that our world deserves products of better and higher quality. And I also love dogs. When I lived in Georgia, I saved more than 50 dogs, and I'm still in this process. I'm still finding new homes for the stray dogs from Georgia. If you want a dog, talk to me, I'll find you a good one. Yeah, let's start. This guy, Ward Cunningham, once coined the term technical debt. And this is the quote from him. He's saying that the term is now misused so much that it's very hard to find a common understanding of this term. But for him and his manager, this term worked really well. You all know this term. We do something now quickly dirty, and then we have some debt that we have to repay. But in his context, this term worked well. Now he's saying the industry is misusing the term. Another guy, Ron Jeffries, he invented the term story points. And he is now apologizing for having invented this term, because he's seeing how much misinterpreted this term is. And this loss of meaning happens way too often in our industry. For instance, when the term MVP, if you Google the history of the term MVP, it was invented and perceived and understood as something completely different from what we use, from how we see it now. Same with DevOps. It was invented as a culture, and now you see DevOps engineers. Quite strange, right? And even in the testing community, still there are so many debates: what are mocks and what are stubs, and can we use them interchangeably? And this loss of meaning disturbs the communication quite a lot. Sometimes even driving us to this stage of the Tower of Babel, where some producers are asking, why don't you use our bricks? And some others are replying in some other language like French that they need to revise the bricks they produce. And yes, we speak English most of the time. Engineers can say, we need more tests done, and managers can say, but customers don't pay for the tests. Or engineers can say, we need code reviews, but other engineers, more experienced ones, can say, they slow us down, let's switch to pair programming instead. Or managers can say, let's release now, and engineers or testers will say, no, the code is still bad. And other cases, many cases, where it seems that we're speaking the same language, and yet we either misinterpret the term or we simply don't understand each other because we are talking from very different perspectives. Like in the first case, we need more tests, but customers don't pay for that. And the result of this miscommunication is quite real. In 2012, $400 million was a loss incurred by Knight Capital Group due to an uncaught regression bug. This famous CrowdStrike accident in 2024 is estimated to result in 10 billion loss across the industry, simply because their configuration system wasn't well tested. And again, in 2024, Boeing had a loss of around $60 billion due to insufficient testing of MCAS system. And that's very sad. So it seems like everyone tests, but results are not there, or results are not optimal, results are not good enough. And I believe that we're all interested, engineers and managers, in doing the right things and doing them the right way. This is more for the engineers. And ideally, managers would trust us, trust our professional ethics, to say that this particular module or this particular device or this particular feature needs more testing in a certain way. And ethics would be just good enough for this whole. Or maybe managers would simply care for users. But it's very hard to speak to managers and investors and any other people who hold the budgets in any terms rather than the money. And that is why I believe that if we frame the way how we reason about testing in the economical terms, we can get much better results, both in terms of higher quality for the product and also in terms of our satisfaction of the work we do. And I think that what's particularly strange and interesting about testing that we have to consider is that obviously testing consumes resources. When I'm testing something, I'm spending my time and I earn money, I earn salary, so this time is essentially money. Testing itself doesn't generate revenue. So if I am testing something, I'm not adding anything to the system, I'm analyzing the test object. And testing outcome, it's even stranger, it's even a more strange thing. The outcome is lack of problems. And it's very hard to reason about absence of something. When you don't have problems, how can you maybe it's just luck that there are no problems, or maybe it's your deliberate work that there is no problems. And let's say we're testing, but we know that we're not testing enough. But there are no issues now, so we need more budgets to do more testing. But it's very hard for us to justify more budgets for something which doesn't generate revenue, and there are no outcomes, there are no incidents. And what's even more strange is that even if we have those additional budgets, then there still might be an incident, because testing never gives you 100% guarantee. So incidents might happen even if we put our skin in the game, even if we promise that we do enough testing. So I believe that all this context makes it very hard for us to talk to managers, to talk to those who have money. But if we frame testing as an investment, at least in my experience for the last 7 companies, it makes things much, much easier. So there is a good definition of an investment, a general definition of an investment. It is an asset obtained at a cost for money on the expectation that it will deliver value. Those of you who trade stocks or shares or anything, you know that you buy it for the money and you only expect that the stocks will rise. You don't have this guarantee. And when I frame testing as an investment which we make today to reduce the probability and impact of the failures tomorrow, suddenly managers understand me much better. And then I add that the risks of not doing these investments should be always higher than the investment costs. So we're reducing the risk. This risk is big, and we're reducing it for this little cost. And so this allows me to start a good discussion with pretty much any manager. And then what I do is I build like a workshop, or you can call it a workshop, where we simply discuss with everyone who is involved in building the product, be it marketers, sales, engineering, product managers, or even finance folks, in this game, in this workshop, where we define what risks and fears we have for the product, which of them matter most, and how we can invest to reduce them. This is very simple. We take the fears of everyone who is involved in building the product, and we brainstorm them. I ask the managers to come up with the risks, to come up with their fears. This is very important from the psychological perspective, because if managers tell me that, for instance, if the clients can't pay for 1 day and this incurs me a loss, the loss of $1 million, then they will be much more open for me to propose a way to reduce this risk. So if they come up with the fears and risks, then it's then much easier. And we can check beautiful body of standards. This particular one is ISO 25010. We can check quality characteristics from this set of standards. They have a very good taxonomy of quality characteristics. What they did when they composed this standard, they analyzed thousands of different products, both hardware and software and even processes, and they made this taxonomy of all the possible quality characteristics. It's like a vocabulary. So I'll show you. Defining the risks. So we sit with the managers, and one of the managers say, if clients, is going to be a product manager, if clients cannot pay, we incur a loss of 1 million a day. This is very important, this in red, 1 million a day. It's him, it's this guy who comes up with this number. It's not me telling him we'll have this risk. It's him bringing this number. I can then map this fear or this risk to two different quality characteristics. First, it's functional suitability, completedness. It's when we don't have the feature for the clients to be able to pay. Or to compatibility, interaction capability. Let's say our interaction with the payment provider breaks. So if we had this feature, then it's only the second one, interaction capability. If product manager comes up with a risk saying that clients can't pay and this is 1 million per day loss, I can tell him that we have interaction capability, quality characteristic being very important, obviously. Or InfoSec guys can say user data is leaked, this is their fear, and we can check with the regulators that it will be 10 million fine. So we will have a fine of $10 million. We can map this fear to security confidentiality. Or let's say UX folks can say that if we degrade the UX of the mobile app, marketers can then say that churn of the clients will increase, let's say 10%. That's their estimate. Any marketer can tell you that if your website is getting slower, then people will leave the website. And we can map this risk to time behavior. Or if we're building a medical device, and we have this risk, obviously, that the device can kill the person if we are unlucky, but it's the risk. The risk is manifested in the revocation of our license. So if we do kill the person, we will lose the license and we will lose the business. So we brainstorm all the fears. These are just 4 examples. We will have like half a day on this exercise, and we will have at least 100 of fears or risks. Then what we can do, we can have a score for all the quality characteristics. So for safety, on the previous step, we agreed that if we lose the license and our company cannot operate, this is the top priority risk for us. Here we can have a table with a score for each risk. Very simple. They can score it themselves. They can agree, the managers, those who have the money, they can agree on what risks are of the highest importance. And of course, from there, we can just define what to do. We can then just see which testing approaches, methods, types, and all the possible testing ways of doing stuff we can apply to reduce the risks. First, of course, we can peek into ISO 2919119, which defines plenty of testing methods. We can ask our team, our dear testers, in which testing methods and approaches they are most experienced. We will then map all the testing methods to that table with the scores to see which are the optimal. And that is very simple again. So for instance, if we agreed that killing the operator for our medical device would be the highest risk for us with a score of 10, and our team knows how to do safety requirements-based testing and fault injection testing, we can put those testing approaches there. We know that these two will somehow mitigate the highest risk. And then for the last 2 ones, we can do the same. We can add testing methods we know how to perform, or we know we have to perform to mitigate those risks. And then we choose those which are the most optimal ones. So higher score means bigger risk. If one testing method is mapped to risks, for instance, see, fault injection testing, it tests recoverability and fail-safe. It appears in two places. Then it means that this testing method applies to two risks. So we do it once and we reduce two risks. That's more optimal for us, right? And here we can also reason about the cost of the testing method. And we can reason about if it should be proactive or reactive. Maybe we should do some shift-left testing here as well. Maybe reactive takes too much time for us. Oh, this is fun. I launched a simple survey to 50 of my fellow testers. And I asked them to map testing methods to quality characteristics. Essentially, I asked them, what testing approach do you think reduces which risk? And they said, pretty much most of them said that unit tests reduce very many risks. I was quite surprised. Maybe my survey was bad. Maybe. I'm not a proper sociologist at all. But my experience shows that without test-driven development, when unit tests are written after the code, they only reduce modularity, reusability, and modifiability risks. They don't reduce safety or anything else, pretty much. But that's just a curious thing I've witnessed. It kind of showed for me that not many people understand which testing methods reduce which risks. And of course, when we did this exercise, this workshop, and we agreed with the product managers, with the finance guys, with marketers, with everyone, that these are the prioritized risks, these are the testing methods to mitigate these risks, we need to review our investment. So we invest in these testing methods, we do this testing, we add more testing if needed, but when time passes, we need to review what happened. Like, did we actually improve our situation? But period of time can be just one signal for the reassessment. An accident or an incident can be another signal for the reassessment, because it might be the case that you invested more money and time in additional types of testing, and yet still you have an incident. And it might be that this incident is just a special cause, that you did everything well, and yet this minor risk still occurred. Or it might be that your investment in testing wasn't sufficient, and you need to revise the testing strategy, redo this workshop again. Or maybe some new regulations emerged on the market, and you need to think about your new risks. So the questions for the reassessment procedure are these. How well are we mitigating the risks? You can invite pen test, for instance, if you're testing security, you can invite an external pen test audit. And they will tell you how well you're mitigating the risks. They will find the issues, or like so many or so few. If they don't find many, then you're mitigating the risks of safety well. How much does it cost? I hate to do time tracking. I simply hate to do it. But I know that I hate to do it when the numbers are misused. When my numbers that I'm like counting what amount of time I spent on what type of work, when these numbers become goals for me from the managers, I hate that. I don't give it to the managers. But I use my time tracking for my own management of my efforts to see how much particular activities cost me, what I can optimize. And this works well for me. And the next question is, can we do it more efficiently? We all know about shift-left testing, but I think that shift-left testing should be applied rationally as well. Like, if we see that we are reactively, after the feature is done, spending too much time on testing the feature, maybe then we should shift left the testing and do requirements analysis or do pair work or do something else before the feature is shipped to testing. Because I've seen cases where the automation testing suite was so nicely done that there was pretty much no need for shift-left testing. The suite was maintained by developers, so developers write the code, developers write the tests, it works automatically really well, and there is little need for shift-left testing. And another question is, maybe we can reduce wait times. For instance, with code reviews, I hate code reviews. I simply believe I know just one context where code reviews work. It's remote teams with zero trust, like open source. In any product team, I think that I can prove that code reviews should be replaced with pair programming, because if you talk to a product manager, how are you going to talk to him? You're going to talk to him in a context of time to market. How soon does he want or she want the feature to be released in good quality? And pair programming is always beneficial here. But again, it's my experience. Maybe in your experience it's going to be different. But if you review how much time and effort you spend on particular type of testing or particular type of review, particular type of analysis, you can then think maybe you can change it to some proactive method, or maybe you can change it to pair or mob or any other type of work. So I believe that when we speak about money, when we phrase any testing activity as just one of the ways to reduce one of the risks, and the managers come up with the financial quantification of those risks, they are much more open, these managers, than to discuss investing more in things we know we should do. And so I frame it for all the managers and developers and testers as well, that testing is an investment in reducing risks. And the risks of not doing testing are usually and should be higher than the investment cost. We cannot test something for a year unless it's required to do so by our own rational reasoning. And so the risks from the managers, stakeholders, users, everyone should come first, and only then we can discuss how we can assess them. And I believe that good common understanding of the vocabulary, which is provided to us by ISO standards, just helps us collaborate better and helps us do our work the way we know and we are sure is the right way. And that's it.
Yay! 3 questions so far, and you're so in time. Okay, if a test method covers more than one risk, how do you calculate the value of this against a single-use method that covers a critical risk?
I love this question. This is amazing. Thank you for that. This is hard. Every model which we build, a model of investment, is a probabilistic model. We cannot properly count it. We can only start using this model assuming that we need, it's better to overinvest just a little than to underinvest. So if there are 2 managers, one of them is marketing person and another is product manager, and they came with 2 risks. And if your test method or testing approach covers both, just invest twice. It's gonna be better for you and for the users. Then, when you see that you're doing some excessive testing, you can reduce the investment. And if test method covers 2 risks, well, you'll just have to think how to frame it to the managers. There is no proper answer. These models are more to provoke you to collaborate better with the managers and establish your model for yourself.
Okay. When managers brainstorm risks, is there a danger that they are all high priority risks and thus more than the team can create tests for?
Yes, it happens all the time, but it's the same thing which happens when you do any backlog grooming or any scenario or any activity where you have to agree what to do first. This is our life. We have to prioritize. You will have to facilitate or invite CEO or someone else to facilitate how they can agree on what's of higher priority, because the budget is always limited. You cannot stretch yourself infinitely.
Okay, actually I wanted to give a like to that as well, but you guys were fast enough. Couldn't we cut down drastically on risks if we fire all the managers?
I'm not sure. I mean, I would honestly love that. I have seen, in my experience, very many managers who did more wrong than good stuff. But I'm now lucky to be working with good managers. And now I've changed my perspective because I'm helping them become better as well. So yeah, ideally it would be like, you stupid, go away, you good, stay. But it's not the reality. We are their direct reports, we are not managing them.
Your managers are here with us in the room now?
Yeah.
Blink twice if you... Okay. Do you consider the probability of risks as well?
I would love to, but I've only done it once where we had this exercise. And this was for a big company where we had a good model of return of investments on features even. So product managers there, they had their percentage of probability of their estimation. So if a product manager comes to you and says, this feature will bring us a lot of good stuff, is this a good probability that the manager is giving you a good feature? No. But if the manager is coming to you and saying that this feature, I'm 50% sure this feature will bring us this and that in numbers, and he has a proven history of doing good estimations, then we can then think and do the probability stuff with the risks as well. But it's very rare. Usually companies are managed in a visionary style, like a manager comes to you and says, we need AI, or we need this, or we need that, let's add this, let's add that, it's beautiful.
That microphone is going into your eye.
Oh,
but it
right.
still sounds great. Doesn't it hurt?
No, it's all right.
Perfect job, okay.
I can talk with my eye.
You can actually, I can see that. What about unknown risks and uncertainty? Any way to properly measure it?
This is beautiful, thank you so much. This is why I like to peek into ISO standards, because my knowledge is very limited. Every individual's knowledge is very limited by the experience and by what books you read, etc. When we peek into the standards, these folks, they spend thousands of hours trying to categorize all the possible quality characteristics, risks, testing methods, etc. So they spend decades on updating and running those standards so that you get better understanding what can happen. Like if you even check, I haven't mentioned quality in use standard, but there is one there as well. It's giving you so much insight into what can happen to your product that I highly advise you to just read the standards. I haven't tried using ChatGPT or any other LLM to help me with the uncertainty because I'm afraid that it will hallucinate too much.
Yeah, good choice. As development becoming faster than ever, how can we justify the amount of testing needs to be done to management enough?
Oh, that's very interesting. So what happens in my experience? First, you do justification for the reactive testing. So you say, we have these risks, we will test them this way, give me the budget, you get the budget or half of it or whatever, but you get some money to do that, you get some time to do that and some effort, man effort. Then you prove that you actually reduce the risks. Then you can talk about introducing more proactive measures. Like for instance, there are very many studies proving that in safety context, continuous training on the job, continuous safety training yields better results than safety procedures. Simply because if people are continuously trained what to do in the worst case scenario, they have drills, they have fire drills or any other drills, they will know where to run with their feet, not with their brain. They will not read some books or some safety instructions. So continuous training is an ongoing proactive measure, and ongoing proactive measures are very hard to justify to managers unless it's required by the regulations. So this is hard. This is always hard. You gain trust by building reactive measures,
by testing and proving that you're reducing the risks. Then you advocate for proactive measures, which are pretty much always economically more sound.
Vitaly, I am probably
Yeah.
going to cry with real tears. We needed
Yes.
to finish by 40. It's exactly... Okay, who sent that last question? I wanted to say, and we finished all the questions. Come on, guys, you sent it in the last second. Let's pretend it's not there, okay? If you were... Big applause for Vitaly. I mean, he did an amazing job up here.
Thank you.